So welcome all. How many of you guys are Angular users? You've used this before. Awesome. Thank you for such a large showing. And I'm sure you guys are all eager to know what's going to happen next, right? And so I'm just kind of curious, who's still on a 1.0 branch? Everybody's on 1.2. All right, most of you guys are on the new branch. Sounds good. Okay, so I want to talk about the future, where I see this thing is going. And the first thing I want to talk about is that we really do love everyone. And what I mean by that is we would really like if currently, web frameworks are kind of an exclusive bunch, whereas if you choose a particular web framework, you're kind of stuck. You can't mix and match different web frameworks on a single page. And we really would love to get to the situation where on a single web page, you could have actually multiple web frameworks kind of collaborating together, and you can choose best of both of any of the frameworks that you want. And I think in that situation, everyone wins. And the goal we're trying to achieve is that we really wanted to lower the cost of writing apps. And I just don't mean just making it easier to write apps, because then you'll get more features. But if you lower the cost of writing apps, then people will end up building apps that were too expensive to build before. So maybe there would be an app that'd be like, yeah, it would be really nice if I could do this, but given the amount of effort it takes, I'm just never going to do it. But with tools like Angular and other frameworks out there, these kinds of apps are becoming more of a reality. And so by lowering the entry, a lot more apps that were just simply not cost effective to build in the past are going to get built. And we fundamentally believe that through this, the world is going to be a better place, because by allowing people to build more of these apps, maybe some of these apps will be used for helping deliver some water to a third world country or something like that. And so by making it easier, like, everybody wins. And so that's kind of my goal. And before we go into all the details, I'm going to give you a disclaimer, which is that this, what you're about to see, is highly speculative. I'm reserving the right to change and renege on anything I say over here. It's certainly not a finished product. This is mostly just ideas in my head of where we should be heading. And the final product will be far, far in the future, in the galaxy far away. So don't expect this to be here tomorrow. Now, keep that in mind, and let's kind of close our eyes and then imagine what the world could be like. So I want to talk about basically four things. One is browsers, then standards, then community, and finally, I have a whole bunch of crazy ideas on how to take this even to the next level. So going forward in Angular 2.0, what would the world look like? And the first thing we kind of decided on is that, there's some browsers out there that are really not that modern, and they have a kind of dying following, and for Angular 2.0, we're simply not going to support that, and we're going to really focus on just modern browsers. And there's a couple of reasons for that. First of all, it's just expensive to maintain them. And the second part is that because we have to maintain these, there's actually certain things you cannot build because these browsers don't support it. And so going forward, Angular 2.0 will kind of be a fresh start and say, hey, we're not even going to bother with something like IE8, for sure not. Where exactly we're going to draw the line, it's not clear whether it's going to be at 9, 10, or 11. But really, we want to say that we really want to focus on the modern browsers, because those will allow us to take the framework to the next level. So let's talk about standards. I think the standard is kind of on everybody's mind, and the people have most questions about is web components. But turns out web components is not a standard per se. Rather, it's a collection of standards. One of them is Shadow DOM. Then we have a way of registering new DOM elements with the parser. That's called a document register. Then we have a template, which is basically just inert piece of DOM. I say inert because if you, for example, load a piece of image tag, and the image has a source, and you put a double curly inside of a source, the browser actually will try to load a URL which is double curly. And so by putting it inside of a template, you are making it inert, and the browsers won't do any of these things. So you can work with the DOM easier. And finally, web components is a way of a packaging standard, which is how do I package my stuff so that other people can bring it into their web applications. So it's not one overall standard, rather it's a bunch of small ones. So let's see how each one of those can help us out. So one of the things we have in Angular, and it's causing a lot of confusion, is we have this thing called the transclusion. And it turns out transclusion is essentially the same thing as a shadow DOM, or rather the shadow DOM's feature called the content reprojection. So if you're familiar with that, it turns out we can just simply replace the whole transclusion confusion that we have in Angular with just shadow DOM and content reprojection. So going forward, this is going to be the way we're going to build components in Angular. We're just simply going to say, we'll just take shadow DOM, and shadow's content reprojection is the feature which we need to make all the components work. And at the end of the day, though, web components are just elements. But Angular actually has a bunch more things that go beyond web components. So for example, when you have a directive, you can have actually multiple directives on a single element, right? And these directives really act kind of like mixins, by which each directive can bring its own set of features or behaviors into the element. This is in stark contrast to web components, which is really, the word component is the key over there. It's really just a single component per DOM element. You can't have two of them collaborate. You can't, for example, have a component that has a tooltip and a component that's a tab. Those two will not cooperate together, right? So you really need the idea of a mixin. And so Angular really goes a step above web components by bringing kind of the mixing idea with directives in addition to components, which are the reusable UI elements that you're familiar with. So, but because web components are just elements, they really means that any author that creates a web component can automatically be included in Angular. And from an Angular's point of view, it's just an element that gets instantiated and an element that you bind attributes on. So any element is automatically available for Angular to be used. In other words, any third-party libraries that are using web components can automatically be consumed by Angular. Now, because web components and Angular components are not quite the same thing, what we're going to do is we're going to provide essentially a facade so that if you wish to take your Angular component and export it so that others can use it as a web component, you can do so. Now, there has to be a facade because really there's a bit of an impedance mismatch in there. Angular, for example, takes a very heavy use of dependency injection, whereas the web components basically takes the constructor away from you, and there's no way to control the instantiation order or the order in which components come into play. And so because of that, there has to be a bit of a impedance mismatch, which we call a facade, that will go into place, so which will allow you to take any Angular components, or rather components written in Angular, and expose them to other libraries just like a regular web component. Obviously, you won't be able to use that with directives because, as I said, directives are this mix-in behavior rather than components being a single component per element. But notice what we're coming to here is that we're really trying to get in a situation where we want to create a world where everybody can mix and match different libraries, different components, and different frameworks to play well together. So the next thing to talk about is there's this new standard called Object.observe. How many of you guys are familiar with it? All right, good number of you guys. What's actually might not be known is that Object.observe was actually influenced by Angular. When Object.observe was being standardized, we talked to the right people, and one of the things we really spent a lot of time convincing, and I'm glad it is inside of the standard now, is that it can observe any object. There are no proxies, there's no getters, setters. And this is important because oftentimes when objects come from, for example, from JSON or from third-party libraries, you don't control the instantiation process and you don't control who gets to read and write from them. And so having it on a native raw object is important. Proxies simply don't work. The other important thing about it is that it needs to be asynchronous. Now, you can always turn an asynchronous API into asynchronous, but because it's asynchronous, it actually turns out it's easier to implement in a VM. The reason why asynchronicity is important is because you can think of modifying a property kind of like a single transaction, right? And you wanted the transaction to be atomic. And if the operations are synchronous, that means as you're modifying the variable, for example, let's say the variable is for incrementing, using the variable to increment the number of items in an array. And as you're inserting items into the array, what you don't want to be doing is constantly updating the DOM as all of the 10 items get inserted one by one. Rather, you want to insert all of them, and then at the end of the operation, it gets notified. Similarly, you can think of it about transferring money from account A to account B. You want to subtract money from one, right to the other. If some listener gets to run in the middle of this transaction, they will see an inconsistent world of what the application actually is. So asynchronicity of it is actually very important. But what Object.observe really brings us is it means that Angular doesn't have to do dirty checking. And dirty checking currently is the only way I know to get this particular behavior that you don't have to have getters, setters, and proxies. And so by not having to do a dirty checking, we can make Angular even more performant than it already is. Now, the next thing is something called DOM mutation observers. And so this is a particular problem that, let's say you have Angular and you want to, you're bringing a third-party widget library, for example, jQuery UI. And jQuery UI has, for example, a UI, they have accordion. And by having accordion, that means that there is some content that's kind of outside, and there's some content that's inside of accordion. And you would like the stuff that goes inside of the accordion to be also data bound. But because jQuery, not Angular, manages the creation of all the accordion stuff and transitioning it, Angular doesn't have visibility of what's going in there. With DOM mutation observers, just like with object observation, Angular can be watching what's going on from the jQuery's point of view, so it can see that the jQuery accordion widget is adding and removing items, and it can compile those items on the fly and insert and remove scopes and worry about memory management that goes with it. And so what that essentially allows you to do through mutation observers is that you get to have any third-party widget library, whether or not it uses shadow DOM, can now benefit that it will behave within the Angular realm as expected. And for those of you that have tried to integrate Angular with other libraries, probably you know that there's a pain over there. And what it allows us to do is it makes the Angular compiler, which kind of matches up the directives against the selectors, to be an implementation detail rather than something that people have to know about on a day-to-day basis. And so that's a DOM mutation observer. So we talked about three things, three standards: shadow DOM, object observe, and DOM mutation observers. But it turns out that even today, most of the browsers don't have these. But our good friends at Polymer, have you guys heard about the Polymer project? Our good friends at Polymer have already been working on writing polyfills. And so we already have a shadow DOM polyfill. We already have object observe polyfill, which is essentially just reimplementation of Angular dirty checking, and DOM mutation observers. And so what we can do with this is we can say, look, we can use these standards, we can use these technologies that's going to be the way the web is going to move forward, and we can rely on these polyfills to bring the behavior down to browsers that might not have these features just yet. It also means that if there's other frameworks running on the same page, presumably if they standardize on these polyfills, on these standards that are going to be in the future, and therefore these polyfills mimic the standards hopefully very closely, that means those frameworks can also cooperatively work inside of the single system. So now imagine what you can have is you can have a world where you can have a component build in Angular and a component build in Ember, and these two components can be on a single page and easily collaborate with each other. And not just be on a single page, maybe they can be actually inside of each other. So maybe the Angular component provides the tabs and panes, and the Ember component could provide like a calendar widget or something like that. And you can easily embed them inside of each other, something that's essentially unheard of today, but it should be able to possible through these technologies. So what these polyfills essentially do, as I said earlier, is that the transclusion becomes the shadow DOM. The object observe essentially allows us to get rid of the digest cycle. And the DOM mutation observers can get rid of the compile. Now, they don't totally get rid of all these things. These things actually become more of like inside implementation details of the system. And I think this is a win for everybody. So now let's talk about a community. So I talked to you about how we're going to structure the system differently so that we can take advantage of these standards. But I want to also talk about how the community can benefit from all this. So currently, because of the way HTML and browsers work, we essentially have this state where people do things like concatenation of strings and concatenation of images and all these crazy things to make the performance and load of the first page faster. I'm sure we all have done this. But if you think about it, it's all crazy hacks that we shouldn't have to do this to begin with. And with HTTP 2.0 that's hopefully coming soon, there is really no benefit in concatenating things. And because things don't have to be concatenated, now you can cache. There is really no benefit in having a single monolithic Angular application. Rather, you can break Angular into lots of small libraries, and then you can rev the individual libraries separately, and you can cache them. But because they're also broken down into individual libraries, that means others can use them without actually having the whole thing. So there's many innovative features that are only inside of Angular. So for example, directives, dependency injection, data binding, our expression evaluator, or the error system that we use for printing out errors. Those things, if you want any one of those, you kind of have to subscribe to Angular today. But what we'd like to do is we'd like to break them up into fundamental libraries. So if you say, I really like the way Angular does dependency injection, but I don't want to use Angular for whatever reason, you should be able to take just the dependency injection part and use it. And maybe even better, maybe other frameworks can say, you know, dependency injection is such a good idea, I'm going to incorporate dependency injection into my system. And so maybe just like Angular has dependency injection, maybe Backbone and Ember and other frameworks can have dependency injection as well. And hopefully, you know, by having these reusable components, we can get in a situation where the community can improve, right? So if somebody in the community says, you know, I have a better idea on how to write a DI container, they can go ahead and write it, and we can just then use it, rather than right now their benefit would be amortized only over a single framework. They could amortize it across the whole community. So we feel like by taking Angular and breaking it up into these essentially sub-libraries, we can help everybody, the whole community, by providing features that can be used in other places. And this actually will help with actually browser load times, because with things like HTTP 2.0, where the cost of having multiple files doesn't add anything, but you do get the benefit that you can cache individual portions of it. Instead of downloading a new version of the whole system, now you can just download new versions of the specific library that actually has the bug or the feature that you need to change. So we talked about breaking it up, and we talked about the benefits that we would provide. So what will Angular become is really just kind of like the umbrella project. So we will still have a download, which is the Angular download, just to make it easy for you. But by breaking it up, you know, things like Bower and Yeoman can actually help you load these and manage these dependencies automatically for you. It is also possible that if somebody were to build a CDN system where all of these third-party libraries could live, the end user could benefit, because by visiting a site that already has seen, the browser can actually pre-cache these, right? And so from one page to another site, if you're using the same version of the particular library, the browsers might already have a cache, and we can have a further speed up for the user. And finally, you know, the community, there's a lot of awesome people out there, and I think if we break it up, it will really allow people to re-implement different portions of it and reinvent things. Like we're already seeing this, that outside of Angular, the people are implementing their own UI routers, they're implementing their own RESTful protocols for REST services and so on. And so we just want to make this even easier for everybody. So let's come to the really fun part, which is the crazy ideas that I have. And as I said, these ideas are crazy. They're all out there, so take them with a grain of salt. But this is the thing that I'm thinking about pushing it even further. So dependency injection. How many of you guys are fans of dependency injection? How many of you guys think it's a bad idea? Nobody? All right, the world has come forward. But most of us know dependency injection in the form of a synchronous system, right? You say inject.get, and you get the object that you want, and you get it synchronously. But we could take this a step further, and we can say, well, what if we had an asynchronous system in which you could say, give me an object, but I don't necessarily know how to get all these things. Now, the reason why this is important is because actually, let me back up. I got ahead of myself. I'll show you an example in a second. But let me back up a second. The reason we want this is that the real goal is to make loading of code easy. And the reason why loading of code is hard is because there's two things at play, which is that one, you want to call a function and you don't know what the function is already there, so you might have to call it through some facade. And second, because the function might not be there, you have to delay. It's not a synchronous function call. Now it becomes asynchronous function call, right? You have to know that if there's a possibility you're going to call that function, and function won't be able to return immediately because the code is not yet there. So by having something that is capable of doing asynchronous DI assembly, this would actually help. Now, this brings us to a much confused point, which is what's the difference between DI versus AMD? Because they kind of do the same thing, and in a way they're very similar. So AMD, or asynchronous module definition, right? Loading is really interested in what order do I load code, obviously asynchronously, and when the code has to be loaded. And so once the code is loaded, the AMD really has nothing to say. It doesn't talk about how individual objects get instantiated. It might give you references to different classes, and so you might load different modules that might give you a different definition of what a class X is, but the AMD really has nothing to say about how X gets instantiated. DI, on the other hand, deals with the order of instantiation of classes, and DI usually is active throughout the application lifecycle. So as the application is running, you instantiate objects, destroying them, instantiating more. Whereas AMD typically deals with just the loading process. Once this stuff is loaded, AMD really has nothing to say about your application as runtime. And so the question on the table is, can we somehow bring the two and merge them together? Because if you think about it, DI deals with objects, AMD deals with classes. But in Java, class and object, in JavaScript, class and object is really the same thing. So why can we just merge this and say, I'm asking for an object that is going to be either a code or instance, but really the details of it are not that important. Let me give you an example of what that might look like. This is pseudocode. This is not real code. But here's an example. Suppose you have a module definition that says, I have a couple of things. I have a size, which is 5. In this case, this is a direct value. I have a users, which is actually a future, which means I'm going to have to go and talk to a server to get the data. And therefore, this particular operation is asynchronous. And I also have storage, which again is loading more code that I need to get. In this case, it's a future for a code. Now you can write a constructor which simply says, if I have a class called app, I would like to get size, users, and storage. Notice in this case, you're not getting the user's future. You're actually getting the resolved future, which is the value. And again, you're not getting the storage future in the last particular part. You're actually getting the resolved value of the future. What it means is that you have to delay the instantiation of app until all of the individual dependencies are resolved. And obviously this thing is recursive. Make sense? So by doing this, now what it really means is that whoever is using the injector, when you say injector.get, you don't get back an object immediately, rather you get a future that eventually gives you back the object. And you're saying, well, you're just kind of shifting the problem somewhere else. That is true, but it turns out that with dependency injection, most code never gets a hold of the injector. Injector is usually tucked away somewhere in a hidden location in the system. And by placing it, most of the places where injector.get gets called is actually inside of the framework. So by making sure that the framework calls the injector in an asynchronous way so that all of the instantiations can be done asynchronously, it actually means that the individual classes, which is as you as a developer get to write, those end up being synchronous. So from your point of view, it's a synchronous world, and when the router navigates to a particular URL and it says, at this URL I have to instantiate this particular controller, you as a developer just write a regular controller with regular dependencies in it, and you simply list the things that you want. And what the framework will take care of is simply delaying of the instantiation of the controller until all of these dependencies are resolved. So this is the idea of a synchronous DI. It does mean that the DI now has to move into the realm of AMD, so that the DI system and the module loading system kind of become a lot more muddled, and there's no clear dependencies, because just as you can load data from the server, you can load more code from the server. Okay, let's talk about next crazy idea, which is zones. Now the goal over here is to remove apply and digest. How many people are a fan of apply and digest? Nobody. Okay, well, you know, I thought it was my greatest achievement to have apply and digest, but we'll go with that. So we really want to get rid of it because it's troublesome. But if you think about what the apply and digest is, it's really a line in the sand that basically divides the Angular world from a non-Angular world, right? Things that are, if you look at the stack frame, and if you see apply.digest somewhere inside of it, the stack above you, you're inside an Angular world, and you know the data binding will work as expected. If on the other hand you are not, you won't get it. Now the trouble is that a lot of things is asynchronous. You will call an XHR, you will set a timeout, etc. And those are ways by which you can essentially fall out of Angular world. And once you fall out, then you have to get back in through this $apply. And it turns out there's just way too many ways by which you can fall out of Angular world and essentially out of the apply and digest cycle. It also means that if you're using existing libraries with Angular, it's not exactly clear what they do internally. They oftentimes might do set timeout 0, they might do other things, and so the third-party libraries that you're trying to use, they might actually do operations that will cause you to fall out of it. And so through all these combinations, it's just a tricky business with this thing. So let's see if we can fix this. And in the process, can we also make stack traces sane? What do I mean by that? Well, oftentimes people complain that they'll get an exception in the system and they'll look at the stack trace and none of the frames in the stack trace actually have anything to do with their application. Have you ever been in that situation? Right? And the reason for that, again, is because of asynchronous nature of things. So for example, your application does an XHR and the XHR causes some error to happen on the server, and you get a stack trace that basically says a server returned 500, good luck. It's not exactly clear what fired off this XHR. And so what really would you like to see is stack traces that go not just all the way up, but really span multiple VM turns, right? So you want to see a stack trace that starts at the top and says, okay, an error happened, but the reason why this error happened is because it was caused by somebody making an XHR call to the server. Why did somebody make an XHR to the server? Well, that's because somebody clicked on this particular element. Why did somebody click on the element? Well, that's because it was registered over here by this directive, and so on and so forth. So that's our lofty goal. How could we get there? Well, imagine this kind of API where you have future1 dot, and you simply say xhr.getURL and then. So there's a couple of things that are going on in here. First of all, there's this get method, right, which produces a future. And then this future, or rather the promise that it's produced, you can have a then on it, so a secondary function gets to run when the future gets resolved, or when the promise gets resolved. And so what you have to make sure is, currently in Angular world, is you have to make sure that the xhr.get actually executes within the $apply. And when the then function, so the fn, also happens later, that also needs to happen inside of apply. Otherwise, you have fallen out of the magical world of Angular. And this is troublesome. Now, compare that with the bottom one, where I'm going to call something new Angular zone. I'm going to explain what the zone thing in a second, but one of the things you could do with the zone is you can say a zone.run, and you give it a function. This is where your application essentially goes. And in here you say xhr, you do the same exact operation. And the zone has this very interesting property that it will automatically make sure that any callbacks registered within that location will automatically execute in the same zone that the original registration took place. Let me have you sync that in. Let me repeat that. So zone will make sure that when you're registering an asynchronous operation, the callback that comes out of the asynchronous operation will automatically execute in the same zone that the original zone you're running in is in. What that means is that the zones now have continuum. Any callbacks that happen will automatically be inside of the correct zone. Now, suppose you have this Angular zone which will automatically call the apply for you. In this situation, you have this beautiful setup where in the case of the future2, you will automatically call digest on the end of the fn function inside of the then. Whereas in the future1, you will not call digest because you're outside of the zone. One of the reasons why Angular actually implements its own future promise systems is because we wanted to make sure that thens automatically happen inside of the digest. We couldn't just take one off the shelf, such as the queue system that our $queue is heavily based on, for two reasons. One is the thens don't execute inside of the apply, and there's no way to put a hook in there. And two, the queue uses something called next tick, and next tick is done through set timeout 0, which means there's a reflow that happens between the resolutions of futures, and that reflow would manifest itself as flicker inside of the UI. So you want to actually do two things, which is you want to make sure that there is no reflow, so things really need to be asynchronous, but things need to appear synchronous even though they're asynchronous internally, and this is done through draining the stack and then reapplying the operations later on. This is all done inside of the digest loop. But you also would like to have a situation that if you could use a third-party library for promises like a queue, if a promise gets created or if a feature gets instantiated outside of Angular, it should resolve without Angular digest, right? It should really be outside of the Angular world. And if a feature gets registered inside of the Angular, it then should automatically be done inside of the zone as well. So this is what zones are. Now, sounds like a good idea. What do you think? Yes? Okay. Any idea how one could implement this? That's the tricky part, right? And now I told you the easy part, right? This is what I want. Now it's just an implementation detail. So how do we implement this? Well, first of all, the zone should be a third-party library, not something core to Angular, but really just something that anybody can use inside of their application. And what the zone really aims to do is simply monkey patch all of the async API in the browsers. So what we're going to do is we're going to take the IDL for the DOM API. We're going to parse that IDL, figure out where all of the asynchronous callbacks are, and we're going to generate a piece of JavaScript that will automatically monkey patch every single asynchronous API that exists in the browser, and we'll redirect that API through a zone. And we'll have something called a default zone, and what the default zone will do is it will just do nothing. It will basically behave just as the browser normally behaves. We'll have no change in behavior. So you basically include the zone.js library inside of your system, and nothing changes. Your system works just as expected. But now what you can do is you can instantiate zones, and you can at will redirect and register and wrap callbacks inside of the system. So what zones essentially do is they allow you to propagate zones across callbacks. The way to think about it is they're kind of like thread locals in Java, except there's no threads in JavaScript. Rather, you have continuations, or not continuation, not the right word because the meaning is something different. You have callbacks, right? So it's like callback local. For any chain of callbacks, zones will make sure that the zone variable is constant. But for different callbacks, the zone variable can actually be different because you could instantiate things in different things. Now, the nice thing about zones is you can actually use them to detect VM turns. And that's the missing piece to make Object.observe work. Because currently, the Object.observe, you have to manually call it every so often. So I'm sorry, the Object.observe polyfill. The Object.observe that's implemented in the browser works as expected because it delivers everything on the end of the VM turn. But the Object.observe polyfill, you have to know to kind of kick it and say, okay, go do the dirty checking. Essentially, you have to do the digest. You still have to remember to do the digest, and if you don't, it doesn't work. But through zones, you can automatically detect when a VM turn is over and call the Object.observe polyfill to do this dirty checking to figure things out so that you can build essentially a transparent polyfill for Object.observe. Now, as I said, by default, you'll have default zone, which behaves just like a regular zone, nothing special. You could also have a stack trace zone, which basically builds you these long stack traces. So whenever a callback gets registered, what you do is you wrap it, you capture the current stack trace, and you wrap it in a piece of code that says, if an exception happens in this callback, when you print the error to the user, don't just print the current exception, but also show the location where this particular thing got registered. And the result of this is you'll get a long chain of exceptions that lead up to a particular error. You could have an Angular zone, which would automatically call essentially digest, even though we're kind of getting rid of the digest in favor of Object.observe. But you could have all the behavior, dependency injection, and all the things inside of it as well. And finally, you can have mocking zones. So for example, for your unit test, you can just install zone.js inside of your test harness, and you can instantiate a new mock zone for every single unit test, and then you could easily redirect all calls to set timeout and any kind of other asynchronous APIs, XHRs, and any other APIs that you can think of. And not only can you redirect, on the end of the test, you can simply throw away that instance of a zone, and a garbage collector happens magically. You're smiling. I like that. Oh, and did I also mention that you can nest the zones? So that you can say, well, I don't want stack traces in production, but in development mode, but in production they're kind of expensive, so I don't want them in there. So I'm simply not going to nest the stack trace zone together with the Angular zone. Or maybe I'll have stack trace zone in the mock zone for the unit test, because hey, in unit test, these things are helpful. As I said, these ideas are crazy. They're out there. Okay, let's talk about the next thing, the language. ES6, have you guys looked at it? It's nice, isn't it? Like, there's lots of nice features in there, but there's two that I really want to focus on because I think they could make our life easier. And they're classes and modules. And the reason I want to look at them is because they make the DI better. And again, I don't want to build Angular on top of something that cannot actually be realized. And so I really want to make sure that there exists a polyfill. And in this case, there exists a polyfill called Tracer Compiler, which is actually done by another group at Google. And what that basically allows you to do is you can either include that as a JavaScript, just like you can do it with CoffeeScript or any other system. In here, you can include these things and you can get benefit from all this thing. This will either compile on the fly in the browser, or you can pre-compile on a server, so you can have either story is supported. Now, why classes and modules, and why do they make DI better? Well, look at a class like this. The trouble with this is what is supported in ES6 out of the box. So first of all, the syntax for classes is nicer. It's not that the JavaScript syntax. The syntax is kind of atrocious. Now, conceptually, it's fine, right? The types in JavaScript are conceptually okay. It's just the way you declare them is really troublesome. But the other problem is the constructor, because in the constructor you say size, users, and storage, and how is the DI system supposed to know what in the world, what these things are? So currently in Angular we do this crazy thing where we take the function and do a toString on it, run a regex and extract the names, and then if you minify it, then you have to do extra work to kind of put all this stuff in there, right? And so what I really, really want is annotations. This is what I really want to say. And what I like about this particular thing is that there's two parts. First of all, notice the add inject part. I can simply say to the system, look, the element you want is actually the type element. So now the minifier is free to take the element and rename it to like a letter E, and it will not affect the dependency injection system. And by putting add inject on it, we can tell the system what exactly do we want. Now we'll come to the add inject later because we can actually get rid of that as well. But the other nice thing about annotations is that if you're trying to write directives today in Angular, there's all these flags and things you can twiddle, and it's a kind of a mystery, and I am kind of sorry about it, but you know, we're learning as we're going, and this is the best we could do at that time. But this is a much better API because what it says is, look, there is an Angular directive, there's a selector, which means that if you come across, oh, that's syntactically incorrect. It's supposed to be not an array of things, it's supposed to be a string with a bracket so that it's an attribute. My fault. I think I can change this. No, I cannot because I don't have internet. Anyway, this selector simply says if you come across an attribute which is ngBind. The second property map basically says that take the ngBind attribute and interpret it as an interpolation, which means double curlies. That's what the @ sign means, and take it and assign it to an ngBind function. And so that actually calls the set ngBind on the bottom. And that basically just says, well, we just want to set the element.text into it. So notice what has fallen out of here. A lot of flags has fallen out of. If you have registered the compiler, if you registered a directive before, you know there's all these flags you can tweet. These flags essentially became the annotations. And the second thing that's out of here is the whole watch. There's no reference to scope. And there's no scope.watch, which is kind of common inside of directives, because all of that actually got pushed into annotations as well. And it specifically talks about how ngBind. The other thing that's missing out of here is the compile and linking functions. There's just really now just a linking, not compile, and we're not even calling it linking. We're really just calling it a directive, or rather just a regular class. It's just a class that has a bunch of methods, and this class gets instantiated when the selector triggers, and we will call certain properties on this particular class when we're ready. But to make all of these things work, you need annotations, and ES6 does not have annotations. So, out of all the crazy ideas is, how about we just take the ES6 tracer polyfill and extend it so that it does have annotations, so that we can do these kinds of things. Now, if you think about what this really just means, it just becomes this, right? So you just have your function, ngbind directive, which takes an element, blah, blah, blah. This is the normal JavaScript definition. And we're just going to make a special property called underscore annotation. It doesn't matter what it is. And on this annotation, we can place all of the metadata that was previously in annotation. So at runtime, we have automatic reflective ability, so we can reflect over all the annotations and we can figure out what is inside of it. We can read it, and a dependency injection can do its job. Now, I mentioned about this add inject. There's another thing we could do is that we could get rid of the add inject if we only had a way of specifying types in the function signature. Specifically, the thing is that you have you have the type and you have a variable name. Now, it turns out the type you only use exactly once in the method signature, whereas the variable name gets used all over the place. And therefore, there's great benefit in renaming it for minification purposes, renaming the variable element with lowercase e into something simple like a letter E, whereas there's not much benefit to renaming the element with capital E. Now, if you look at most systems, they treat the field on the left and the field on the right as two separate and distinct things, right? So there's a namespace of types, and there's namespace of variables or parameters. And those two things should never meet. So you could actually, in Java, it is possible to have a variable capital X and also have a type called capital X. And the two will not collide. They will not shadow each other, and you can write bizarre statements. Like you can say X space X equals new X, right? And the compiler will not get confused. And at no point will there be ambiguity. So if you actually going to try to do something like X equals X, the compiler will say, no, the right-hand side is not a type X, it's actually the variable X, and so X assigned to itself, when you're declaring it, no fly, so that's not going to work. So those things are actually two separate namespaces. One of the things I think the JavaScript got right is that there's no distinction between code and types, right? If you have a type, which is, in this case, an element, it is indistinguishable from having a variable element, and you can take that variable and you can easily assign it to a different variable, and then you can call a new operator on the different variable, and it's as if you called a new operator on the original one. So when you look at the signature like this, actually all of these things are parameters. This is as if you put a comma in there, right? It's element comma instead of a colon, right? And a second parameter, which is element, whereas one gets to be renamed, the other one doesn't, and we kind of skip one. But that's not important. Well, the point is that I really want to treat them as the same thing. I don't want to have types to be a separate namespace. So now, as you can see, we can get rid of the add inject by placing it inline in the element. And we get the benefit that we can actually have the dependency injection kind of assemble the system with just very little information. And as I said, this is how we could store all of this information in the system. You can see that the arguments could be type annotated. We can put the annotations on the fields. So all of these things can be in there, and types and variables are really the same exact thing. Now, why am I talking about types? Because I've been doing a lot of thinking about types, and I've come to this conclusion that static types kind of spread like cancer. Now, there's really two camps in this world, and one is that they like types. They think the types is the best thing ever, and they saves you from everything. And there's other people who think that, oh, types are just like the name suggests, a whole lot of typing. I know it's a subtle joke. I kind of go back and forth in this particular world, and the reason I go back and forth is I kind of realize that when I write super complicated code that is very abstract, like, oh, I don't know, the Angular compiler, I really miss types because I get very, very easily confused what exactly this variable holds. Is it an array of this? And it's not, the real problem is that if you're writing something like a compiler, everything is abstract, right? You don't have things like ngbind and things. You have directives, and you have multiple directives, and you have to sort them to apply them in the correct order, and you have to instantiate them, and your head gets lost. And so having types actually helps. But types come at a cost. They're not free, right? And so the question is, do types pay their rent? And I think it's really a question that has to be answered on code-by-code basis, right? Sometimes they're worth it, sometimes they're not. Now, the trouble with static types is the word static is important because it means that they can be analyzed at static time, right? At the compile time, not at runtime. And the only way you can analyze it in the system is that they have this spreading like cancer property. So you have some variable called x and it's a string and it's assigned from calling a function foo. Well, all of a sudden the compiler is going to go on fritz unless you also tell the function foo that it's returning string. But now the compiler is going to be happy about the assignment, but it's going to go on fritz over the function declaration because you just told me you're returning a string, but I can't verify that you are indeed returning a string. So now you have to go into the function and then annotate those things, right? And you see how you're just unwinding a sweater and you just start pulling and the whole sweater comes apart. So they have this really horrible property, which I'm not a big fan of. And so really what I want is optional types. Things that I sometimes get to have them when I feel like the benefit is there, but other times I don't want to pay for them. The other trouble is, if you have a static system and you have a third-party library like jQuery that's untyped, how do you consume something inside of the system? Then all of a sudden you're in this world where you have to go and write either an extern file or some kind of a thing that types this untyped library. And it's really just a big pain. So now, there is a lot of different things about types, and I really don't want to get into all of them, but I just want to give some examples. I'm not saying one is better than the other. I'm just trying to make sure we're on the same page here. So static types, an example of that is, and by the way, I haven't used TypeScript, so I could get this wrong, so I apologize if I do. But I believe an example of a static type system is a TypeScript. And it is a type system that's known as structural, which means if it looks like a duck, it quacks like a duck, it's a duck, right? So if you have the right set of function names, fields, etc., then you are of that type. But again, this verification has to happen at compile time. This does not happen at runtime. This is a compile time verification. And as such, it has this property that it spreads like cancer. On the other end of the system, you have optional types like Dart. And in Dart, you don't have to declare a type if you don't want to. But if you do, it actually turns out that it's meaningless unless you run inside of what they call checked mode. And in checked mode, the Dart compiler or the Dart runtime generates an extra if statement that basically says, if you are not of the type you are supposed to be, throw an exception. Right? So it's kind of a runtime assertion of the type system. And this gets rid of the ability to have a system where it spreads like cancer. Because you don't have to verify at the compile time that a function foo returns a string. It's sufficient to you when you're doing the assignment to a variable that is string to verify that it is indeed a string. And if you develop your code base and you run with these checks on, and you keep developing and you build the whole system, and at no point the system fails on this particular check, then it's safe in production to remove that check and not pay the penalty. Right? So you have the benefit of having types when you want them, but if you don't want them, you don't have to. Except that Dart is a nominal type system. That means you're a duck if you inherit from a duck. And that's not the same thing as what JavaScript is built on. Like JavaScript is really about structural typing, not about nominal typing. So it doesn't quite fit our model either. Now, there's type inference, and type inference is really just a static type system with a lot less typing because we can infer some of it, but it really doesn't make the problem go away any easier. And finally, there's this whole problem of JSON JSON and third-party libraries inside of, and I'm out of time, out of the system, which I don't want to get into because I'm out of time. So what I'm proposing is that we could have types as contracts, which is essentially an assert statement, right? These will give you the benefits that you want during the production, during your test, etc. But then at runtime, you just throw them away. And a contract is a function which is evaluated at type declaration. So let me give you an example. These are all the places where you could generate, and the functions could be composable, and you can even do things that you cannot do with type systems. For example, you could say, I want to have a list of CSS selector strings. Such thing cannot be expressed in any type system I know of. But with assert functions, you can, or the contracts, you can very much do that because you can write a function that says, anything that passes this regex is a CSS selector. And then you can have another function like a list, which is composable, which adds the two together to allow you to have things like that. Anyways, this is the result. And questions? Do we have time to, microphone? We have to get you to a microphone if you have a question. It is online. The URL is on the first slide right here. And I will tweet it. I'm not sure the microphone is on, so I'm going to repeat. What is the downside of zones? Is there a memory footprint? The default zone is essentially free because it adds a cost of one stack frame on your any call. And because entering a VM is already so expensive, the additional stack frame is essentially nothing. So the default zone is not going to cost you anything. Additional zones that you write, it really depends up to you how expensive or cheap you want to make them. So a stack tracing zone was actually going to be relatively expensive because capturing stack trace is just expensive.
Oh, I just want to add one more crazy idea to the bunch. It's shadow scopes, which can hide some branch of scopes from digest cycle to gain performance.
Yes, shadow scopes, good question. We're hoping that Object Observers will make the whole object, the cost of digest just go away, and none of this thing is going to be necessary. So we toyed with this many times, but we're really hoping to just like solve the meta problem rather than a specific symptom of it.
Yeah, thank you.
Thank you, guys.